What's up?
Yeah, so just
So,
I started that test right now,
okay.
and I'm stuck on one. If you want. Well, I just don't know how to.
Carolyn is using using the table.
Yeah.
So
I was trying to I don't know what freaking. I have no idea. I was trying to just do multiplication and divide on this.
Yeah, it looks like you're supposed to do okay, what is the value of x and y? Okay. So on this one, it says they're trying to figure out 360% of 15. So then it lists out 100, 100, 100. That's, I think, the 300 part of it. And then 20, 20, 20 is... Yeah, so all of it is to figure out some percentage of 15. So if you just did 100% of 15, what would that number be?
Be 50%, right? Or what do you mean?
It would just be 15. It would 100% of the value of 15 is just the value of 15.
15%.
Yeah, I don't know, 50% would be half of 15, which would be 7 point. So
7.
So I think in the 100% spots, it says X. So I think 100% of 15 would be 15, 15, 15. So X would be 15. So it's either one of the bottom two. And then
the Y would be the 20%, but
20% of 15.
Okay.
And so how do you figure that out?
It'd be 3.5, I guess, if you were to...
Yeah, if you round, I think it's... Or, let me see.
But it would be the 15Y then. 15X and then Y3.
Yeah, let me see. Yeah. Y is 3, so the third one. Did you do 0.2?
Okay, that's how they got it.
Did you do 0.2 times 15?
No, I just went straight on the calculator and did 15 minus the freaking what the hell did I do? Did minus 3%. Wait, 15 minus.
Because the way I was thinking of it was like you get 100% of 15, which is just 15, and then 20% of 15. And the way you do that is you move the decimal over twice on the percent, and then you just multiply 0.2 times 15.
I think you told me this on the last time on Monday, but if it's 360%, and there is no decimal, would it go 0.360 or does it?
Okay, so yeah, if you weren't using the table at all, and it just said what is 360% of 15, well, you go on the percent and move the decimal over twice, and then that would be 3.6. And then take that.
Well, so no matter what, so if it was 360, then you would move over from the percent 1, 2. So it'd be, so if it was 150, it'd be 1.50.
Yep.
Well, it's always twice.
Always twice for percents, yeah.
And I've seen a video that I did one of the tests, and the guy moved it to the right, but that was on some other. It was a pre-test, dude. I watched it on YouTube.
He moved it to the right. He was doing something.
With the percent, it was to find the total amount, or either I don't know, from the decimal to the percent. Or
yeah.
I think he was trying to move.
I mean, it's just if you go from a percent to a decimal, you're moving the decimal to the left. If you're going from a decimal to a percent, then you're moving it to the right. I like we'll see an example probably, and I'll explain. I think what that part, what I'm thinking
All
of.
right.
All right. And there's what 25 questions on this one.
I believe so. I'll skip to the next one. Most of the time with the 2 hours, yeah, they give you
Oh, okay. All right.
25.
The Bishop family celebrated a birthday by dining out at a local restaurant. Their bill was $97.45. Mr. Bishop would like to leave an 18% tip at the table for the server. What is the total amount the family will pay for the dinner? Round to the nearest cent if necessary.
That one ain't too bad, right?
Yeah, what would you do for that one?
So I got it right now, and it's $114.99, and all I did was the simple, because I remember when I used to go to like the outlets and stuff like that.
Yeah.
And I would just freaking, it would be like a shirt for 30% off, right? The shirt cost $88, and then I would just minus 30% with the little percent sign, and
Okay.
it give me the quantity. So right now I just did the 97.45, and then I just added the 18%, and it gave me $114.99.
Let me double check that. I've never used the percent button,
Yeah,
so 97.45. Wait a minute. So 90. What did you do? 97.45, and then what?
And then I hit the add button,
Plus
18, and then the percent.
18% equals. Oh yeah, there you go. So right before
I mean, that's the easy way.
Yeah,
but I don't
is
know
super
if
easy.
that's the right way.
Yeah, that's it. When you push the percent button, like if you just did 97.45 and then do plus 18 and hit the percent button, right there the number changes to 17.54. Shoot, that's the easiest way to do it. Like,
yeah, that's what I was doing on the last couple the last pre-test, and I got 100%.
Yeah,
but they were all simple questions. They weren't nothing.
So it tells that 17.54, that is 18% of 97.45.
Yeah, because the way you would do it, right, would be 97.45 times 0.18, right?
Yeah, and that would give you the 17.45, and then you just add that. But, the other way is faster, so let's do that.
It's cool. It's easy, yeah. It's easy.
Yeah. So what do you think on this one?
So he's going to reduce the membership fee by $5. What is the approximately percent? Okay. Try to find the percent. I'm just going to go off 35, and then I'll minus 0.14. $0.14 ain't for sure. It's not it. 35 minus 14%. So it'd be the 14%. It's 4.5.
Yeah, I get how you're doing that. Yeah. Yep. So you did 35, and you did minus, and then
the percent, or minus 14, and then percent.
Percent button 4.9 equals 30. Yep. Okay. Cool.
I think we did that one last, or maybe I did it, but it was worded differently.
All right. Rachel finished a meal at a diner and received a bill for $10.99. She charged the bill along with a 15% gratuity to her credit card. What's the total amount? Okay.
It'd be the same.
Same idea.
Same concept, yeah. $12.64.
Yep.
That's what I got.
Me too. I didn't even realize there was a percent button on the calculator.
Yeah, I remember I used to go to the stupid outlets all the time, and I would try to figure out how much would I end up paying. What is the total amount he'll pay the drivers? $42.60.
Yep.
I'm telling you, some of them were super easy, so I was like, man, this is. But these are the ones
now the ones where they make you do it all weird.
That's when I get lost because I'm so used to using the calculator.
If Allison wants to find 80% of 630, which table should she use? So I think for the tables, all of the like percentages have to add up to 100%. So 20, 2, 4, 6, 8, 10. And you have to be able to get to 80% with them. So like 1, 2, 3, 4, 5, 2, 4, 6, 8.
That 40% one then is wrong, right?
Yeah, because it doesn't add up to 100%.
Yeah.
And then the 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 8 times 12.
Equals 96. So
yeah, that one. So it's got to be the first one. And my guess is that because it's 2, 4, 6, 8, 10. So that's 100. And then she could use 1, 2, 3, 4 of those and add it together to get 80%. That's so weird. That is the first one, yeah. Yeah, so with the box or with the chart like this, the top percent has to add up to 100%, and also you have to be able to use not all of the boxes, but sometimes all of the boxes to add up to 80%. So
okay, so it doesn't have to be all the boxes.
Right. So that's why the second one doesn't work, because if you do 25 plus 25, that's 50%. Plus another 25 is 75%, and then plus another 25 is 100%. You never actually get 80% from that second chart.
Yeah.
So even though it does add up to 100%, it still has to like partially add up to the percent that you want to calculate. So that's why the first one works. Okay.
I'll try just doing the simple math on here. I mean, the first one could be used, but we can try them all just to.
What did you get? Which expression could be used to determine the cost of a $50 video game after a 20% discount? Did you get a number for that after you just do that regular in the calculator? 50 minus 20%?
Well, I did 50 times 0.020, and I got $10, so it'd be $10 off. I would figure.
Yeah.
Then I did the 50 minus the 20%, and it gave me 40.
Yeah. So for these expressions, I think they're asking which one gives you $40.
So it has to add up to just by doing the way they did it, right?
Yeah, I think so.
So it'd be D.
Yeah.
Good enough.
So on that one, the 0.8, when it's a discount, they took like 100% minus 20% is 80%. So the rewording the question, instead of $50 video game with 20% off, that bottom one, a different way of calculating it is instead of 20% off, just make it cost 80% of what it used to cost. And so that's what that calculation is. But it gives you the same thing. So
That's pretty cool.
I would just do, 50 minus the 20% and then type all those in and see which one gives you the same answer.
So that's it, right?
Yeah, it's the fourth one. Yeah.
What did the B get you?
So for me,
50 minus. Well, you'd have to do the 50 minus the 0.8 first, right? Or
I get 46. Like you could do, because it has those brackets.
Yeah.
So you could do the 50 times the 0.08, and then you get 4. And then so you do 50 minus 4, and you get 46.
Okay.
When a fish count goes down from 850 to 500.
So like this one, the easy way I would do it is just do 850 minus all the percents in the the answers, and then usually I'll get it then.
Oh, it's approximate.
So it'd be the 40 because everything else is a little outrageous.
Yeah.
That one gave me, I think, like
510.
510, I think, yeah.
Yeah, that's the one. Ileana's math grade increases from 65 to 85. Fiona's math grade increases from 70 to 80. What is the difference, rounded to the nearest whole number, between the approximate percent increases? Do you know how to do this one?
I would just do the 10% to see for both and see where it goes, you know.
So, but it's asking you what is the difference between their percents.
Oh, okay. How would you write it out? I mean, we can go. We still got time. I think I should be.
Okay, let me. 65 turns to 86%, and 70 turns to 80%. And then what is the difference between the 2% increases? Okay, I'm going to share.
Round to the nearest.
So, percent increase. Let's see, 65 to 86. What is the percent increase? 60. I'm just working out some stuff. 1 point something.
Okay.
6. I'm gonna explain it afterwards. I'm just trying to figure it out. So 60. What if I do 86 minus 65? 21. So I'm going to do 21 divided by 65 equals 32. So 65 plus 0.32 equals. Plus 32% equals 85. Okay, so this is what I'm thinking. First, it's kind of complicated, but to get the percent increase, that's what we want, right? So I just took these and subtracted them, and I got 21. And then, because that's how much I increased, right? The number of points I increased by 21. But it's asking the percent increase, not the number increase. It's asking for the percent increase. So I need to figure out the 21. What percent is that of 65? So I'll do 21 divided by 65. So 21 divided by 65 equals 0.32. I'm just going to round it. So that means 21 is a 32% increase because it was 0.32. To change it back to a percent, that's when you move it to the right.
Okay.
Does that make sense?
Yeah. That's what I seen that you did there. Yeah.
Okay, so just to make sure, in the calculator, I'm going to do 65 plus 32%, and then see if I get something close to 86, just to check. So 65 plus 32% equals 85.8. So that would be it. Does that make sense?
Yeah, I see. So what would the answer be, though? There is
so
no 30.
Right. So it's asking for the difference between this one and this one, which means you just have to subtract them. So we still have to do the same exact stuff for this. So the difference here, or the increase, would be by 10 points, right? But we want the percent increase, so I have to figure out, so this would be plus 10. So I need, what is the 10% of 70? So I would do 10 divided by 70. So 0.14, I'm just going to say that. 0.14. To change that to a percent, you move it over twice. So 14%. And then now it's asking for the difference between the two. So I'm going to do 32 minus 14. 32 minus 14. Is 18 there, or something close?
Yeah, it is. It's 15 and 18.
So I would say 18.
20. That's crazy.
So we got first the increase, and then it was asking for the percent increase. So you would divide just to get that decimal, and then to change it into a percent, you move it over to the right, and then do the same thing on this side. But then it was asking for the difference between the two, so you just subtract, because difference just means subtraction.
Right.
That one's
I guess I can watch the video.
Yeah, that's a crazy one.
Yeah, because I'd have to watch it. Because I did watch the last video, I think, when I was doing, when the guy moved it to the decimal. So it was a worded question, and the first one, if it would have been like 70, that's the one based off, right? Because that's the first step. Then you round off either to 100 or whatever.
Yeah.
I forget exactly.
I don't know if you shared it yet, but I can't see anything yet.
Oh, I'm going right now.
Oh, okay, cool.
Right when you said, I clicked it. And then...
Cool, I see it now. All right, Raymond bought a used truck for $18,800. If the sales tax in his state is 7%, what's the final price? Okay, that's an easy one.
I did. Yeah, this one's an easy one. I did this. I think it's like 116, I believe.
Yeah, that's what I got. The third one. Board game that normally costs $30 on sale, 25% off. What's the sale price?
There's another one of those.
Mm-hmm.
Easy moves. 22.50. Yeah.
Yep. Man, it's super nice when you know how to use the calculator.
Yeah, I know. It's easy. It's too easy.
I didn't even like realize that. That's super nice. Okay, so percent increase. So this is what we just did on the other one. First, you have to figure out how much it increased by in dollars, and then divide to figure out the percent. Or you can just try though. Actually, that's what you probably do, right? You just try each one of those. 800,000 plus 13%, 800,000 plus.
To get the 900, yeah.
Yeah. Well, I think it's.
That'd be the easy way, but I don't know.
No, that's. If there's an easy way, do it.
So 13% gets you to freaking. It gets you close, 904.
Yeah, that's going to be the closest one, so. There you go. Count went up for, what is it? Same thing.
Same crap. Be the first one again?
I think so.
I'll try the second one.
Yep, no, it's the first one because it's 598.
Yeah, that one.
Yeah. Boots his original price to $95. They're on sale for 30% off. Oh, that's. I mean, you could just.
So
try.
This one, what I did when I got it, I just multiplied the percents until I found out because I did this one. So I just multiplied 0.35. Didn't get it. I think it was 60. I'm not sure though. Let me check it. Either 60 or 65. Not that one, so it's good. Or maybe I was wrong. Yeah, so it's the 65.
Yeah, that's what I got. Harley posted a story on her blog. On the first day, there were 80 responses. On the second day, there were 180 responses. What percent increase? 100 of the original number of responses, 80. What percent is the increase?
So what's it actually asking?
So like if you were, so 50% of 80 is 40, right?
Mm-hmm.
So if you added 40 to 80 and got some number, that would be a 50% increase. Well, right now they're adding 100 and they're saying what percent increase is that? So you could do 80 plus 55%. Does that give you 180? Or 80 plus 80%, does that give you 108? And then just keep trying it like that.
It'd be the 100%, right? Well, I mean, 125 got me 100. This is when I multiplied it. I should just be adding.
You should just be doing the same, like 80 plus 100% equals, or 80 plus 125% equals, and see what gets you to 180. I mean, that's the way that we've been doing it with the calculator.
Yeah.
It'd be the
125.
It'd be the 125. Here's one way that you can think of it, because it's asking what's the percent increase. if you think about what's 100% of a value of 80, it's all of 80, right?
Be 80, right? So it'd be 160.
Yeah. So it's adding 100, and that's more than 80, right?
Yeah, that's what I was
So
thinking right when you explained it.
yeah, the 100 is more than the 80, which means 100. If you add 100, that's adding more than 100%, and the only answer that's more than 100% is the last one. But then you just check it out with the calculator, and it works. Why is the percent increase from 45 to 75 not equal to the percent increase from 75? Oh, select 3 options. Oh, this one's a hard one.
So this one I would be trying to figure out the freaking percentages of both, right?
Yeah, that's um. Oh. Hmm. So it's definitely not the first one. The amount of change is different for the percent increase and the percent decrease. Uh, the amount of change is the same. It's just one went up and one went down, right?
We have to choose 3
Right. So
ratio.
I'm just trying to figure
Increase.
out which 2 are wrong, and then the rest of them are right. The first one is wrong. That's for sure.
I think the second one is either right. It's wrong. It's right. It's not right. I mean,
The ratio of the percent increase is not the same as the percent decrease. I think that one might be right. I'll write it down afterwards, but
all right.
the ratio of percent increase has smaller denominator than the percent decrease. That's also true. The ratio for the percent increase has a different numerator than the percent decrease. No, that one's not true. It's the second to last one and the first one that are wrong. The original amount of the percent increase is different from the original amount of percent decrease. All right, since we only have 5 left here, just let it play because I'm just gonna work it out, and then we'll see. So don't like save it and exit. Just leave it, and then I'll share. All right, so one of them is going from 45 to 75, and the other one is going from 75 to 45. So the percent increase, the way you get that is by figuring out how much you have to add, and in this case, just 75 minus 45. What is that? 75 minus 45 is 30. So we're adding 30 here, and on this one, we're just subtracting 30. That's just the regular increase and the regular decrease, not the percent.
Okay.
If you wanted to figure out the percent decrease, then for that, you would have to look at 30 divided by the original 45. So 30 divided by 45 is 0.6. So 0.6
ongoing
forever. So repeating. But that's the decimal, and then as a percent, you move it over twice, so that'll be 66. And then since there's infinite number of sixes, I would say 66.6%. So that's the percent increase. So you figure out how much regular increase was, and then to get a percent, you just take that and then divide it by the original, and then make it into a percent. So we'll do the exact same thing here. So it's minus 30. So 30 will go on the top because that's just the amount changed. 75 on the bottom. So 30 divided by 75.4. So equals 0.4. So as a percent, 1, 2. So that would be 40%. So the percent increase is 66%. The percent decrease is 40%. One of them said that the percent increase ratio, the ratio for percent increase is different from the percent decrease. That means the fraction, the ratio. And these are different because of the bottom number. So that answer is correct. Then it said, like the percent increase is different from the percent decrease. That is also true. And I think the other ones were, I can't remember. Let's go back to what it said.
I could, I'll tell you. Oh, you already have the answer, so I can go back.
All right, so this first one, the amount of change, okay, that's why that one was wrong. The amount of change was by 30. So the amount of change was the same.
For both.
Yeah. It's just one was up and then one was down. So that one is incorrect. The ratio of percent increase is not the same as the percent decrease. So the ratio that they're talking about is the 30 over 45. That's for the percent increase, and then the 30 over the 75 is the percent decrease. So the ratios are not the same, so that's true. And then the next sentence, the ratio for the percent increase has a smaller denominator than the percent decrease. Denominator is the bottom number. So on the
45 on.
Yeah, the left side, the denominator was the 45, and then the right side was the 75. So, I mean, that's also true because on that left fraction, that left ratio, the denominator was smaller. The ratio for the percent increase has a different numerator. That's the top number. They were both 30, so that's why that one's wrong. And then the original amount of the percent increase is different from the original amount of percent decrease. That's just the 66.6666% and then the 40%. All right, so we're good on that one. Yeah, that was a crazy one.
Yeah, those are pretty tricky.
Tanya's Swim Club increased their $29 membership fee by $6 a year. Oh, it kicked you out.
There we go on this. I don't know why I was doing this crap.
If you log out, it was still saved, right?
It'll save that one. I think everything that we've chosen.
I think that happened one time.
Yeah, it should bring me back to that one. It didn't log me out. Should have logged me out.
Yeah, that's weird.
It's always around this time. either 9 or 8:30.
Damn.
The next one was freaking finding the primary numbers or something. So that one was like, 1 is not a primary number, but 2 can be, and then like 5 and then 7. And
okay, yeah.
I didn't get too much into it.
Okay.
That's like the next course, the beginning of it,
Yeah, we can do that.
The first lesson.
Does it ever not let you log back in?
It'll do something like this, but eventually I'll get in.
Okay.
It's never too long.
So, yeah, prime numbers are the ones where you can't divide by anything evenly except for just 1 and itself. So, like, 1, just by the way they did the definition,
Yeah.
1 is not a prime number. But 2 is a prime number because the only thing that you can divide into 2 is just 2 and 1. 3 is a prime number. Like, you kind of got to get used to it, but we'll talk about it when we get to the lesson.
Yeah, I started watching a video on it, and this guy was like blocking out all the numbers that aren't, But I didn't get too far into it. I just wanted to see what it was.
Okay. All right, Tanya's Swim Club increased their $29 membership fee by $6 a year. What is the approximate percent increase?
This is one of those easy ones.
Yeah.
Would be the first one, 20%. You get 34.8.
Yeah, me too.
It'd be 35.
Yep.
$36.
Yep.
What is the amount of the discount? It'd be $4 then, right?
Oh, yeah, good catch. I didn't catch that.
Yeah, because I remember I started rereading them just to make sure.
Good idea.
Yeah. By the way, we wanted it too.
That carries. How many can you get wrong out of the 25?
I got to get at least the 70%, I believe.
Oh.
So maybe 5? I don't know. This one, I got it last time. Just like two guitars. It's the second guitar for sure.
Yeah, that's $200 off.
Well, the first one's 60 off, right? The second one's 100.
Yeah.
So it'd be what is it then?
Well, let me see.
Would be the 40%, I thought. Or no, let me.
So that'd be the first one.
Yeah, it'd be the 40%.
And then 2. Yeah. So what did you do?
The same. I just minus the 40% from the 250 and got 100 off. Them is the other ones.
Cool. The attendance at a seminar in year 1 was 500. In year 2, the attendance changed by 100. What is the percent change in attendance? So I think you could do What percent change? Change by 100.
So I can do the 500, you think, and just add the percentages
Yeah.
and see which
And
one
then it
gives me.
should, yeah, then it should end up at 600. That's the one that you're looking for.
All right, yeah. All right. I think that's the 20%, right? Cause yeah,
Yeah,
that 40 gave me 200.
500 plus 20%. Yep. Oh, select 3 options. Okay.
So this one I'll just do each one, I think. So I'll do one minus 5%.
Okay.
I know for sure the or George had a greater percentage, right? Just from the numbers itself, because he lost 15 pounds, she lost 10. And man,
Well, wait, Marie's weight went from 75 to 50.
or Marie, yes, it's big. Marie had a greater, yeah,
There we go. Did you? So it says Jorge's weight change was approximately 5%. Did you get that? Did you use that? 190.
yeah, I got like 166 or something.
You did minus 5%.
Yeah, I could do it the other way.
Well, 190 minus 5%. That's 180.5. That's what I got.
Yeah, okay, then I must have done it. I'm gonna do the so 5 times 0.05 equals. You got off of Jorge's weight, right? Yeah, so okay, I was going off. I'm still going off Marie's crap. Never mind.
Oh, I see.
Yeah, okay. Yeah, so it would have been 9.5 pounds. So that one's right. And then I just figure out hers.
Marie's weight change is approximately. Okay, so.
Minus. Yeah, so it'd be the second one too, the 14%.
Yeah. You just did 175 minus 14% in the calculator and see if it got to 150?
Yeah, it gave me a 24.5, so it would just minus.
Yeah, okay.
What you got?
Sweet.
They didn't think I'm cheating. Just kidding. That one's done. And when you can just, if you have time or whatever, we can
Yeah, let's do another.
just show me that, or give me some type of, yeah. See, so it's 2 of them.
Prime numbers and prime factorization. Okay, so before we start, let me do this. Let me share. Okay, so prime numbers are one, like, I'm just going to do the same thing that they did. 1,
Okay.
2, 3, 4, 5, 6, 7, 8, 9, 10. Just up to 20.
How high can a prime number go?
Infinitely high. Can keep going
So it'd be
forever.
like 57 and random.
Yeah, it's so like there's a way to test it out, and that's what the prime factorization is. So I'm just gonna do up to 20 here. 18, 19, 20. So we could keep going on and on and on forever, but the prime numbers are ones that you can't divide it by anything except for itself and 1. So like here on the, I'm going to start with 20. I could divide 20 by 10, it would give me 2, right?
Yeah.
So this one is not a prime number because I can divide it by 2, I could divide it by 10, I could divide it by 5, I could divide it by 4, and they would all work out. 19, on the other hand, like if I took 19 and started trying, 19 divided by 19, that works to a whole number, 1. 19 divided by 18, of course, is not going to work. And then you just try all of them all the way down. 19 divided by 5, nothing. 19 divided by 4. 19 divided by 2. Like, none of it's going to work. And you could just try that all the way down. 19 is a prime number. Because the only one that works is when you go 19 divided by 19, because that equals 1, and 19 divided by 1, that equals 19. That's the only way you can get whole numbers. So that's, by the definition, that's what a prime number is. 18 is not a prime number because you can divide that one by 2 and by 9, and it comes out evenly. In fact, all of the even numbers you can divide by 2. So none of the other even numbers are going to be prime numbers, except for 2 is a prime number because you can only divide 2 by 2, and you can only divide 2 by 1. But by definition, 1's not a prime number. That's just something that they decided. 17 turns out to be a prime number because if you try to divide it, then nothing else gives you a whole number except for 17 and 1. 15 is not a prime number because 15 divided by 3 gives you a whole number, and 15 divided by 5 gives you a whole number. So there's more than that. 13 is a prime number. 11 is a prime number. 9 is not a prime number because you can do 3. 9 divided by 3 is 3, so that doesn't work out. 7 is a prime number, 5 is a prime number, and 3 is a prime number. You could keep going on and on and on and on and slowly figuring out stuff. Yeah. That's just the idea of prime numbers, just that.
Okay.
The next thing is prime factorization. So prime factorization just means, like if I take the number 15, the prime factorization is what times what times what times what, like what numbers are what prime numbers actually. So from this list that I circled, what prime numbers can I multiply and get 15? And there's easy ways to figure that out. So that's the question. That's, if we answer that question, we will also have the prime factorization. But it can only be prime numbers. So
5 is not a prime, right? So
it is a prime.
5 is 3, 5, right?
So 3 and 5, this is how I write it, just 3 times 5. So the prime factorization for 15 is 3 times 5 because this is a prime and this is a prime. If it was like 6 times 3, this would not be a prime factorization because 6 is not a prime number. So I'm going to try and do a little bit more complicated problems. But 15, the prime factorization is 3 times 5. When you factor something, it just means to write it as something times something else. But you can do like 3 things times each other. You can do 4 things times each other. So I'm gonna just do like 2 more examples, and then we can try the problem set. But if you had like I don't know, let's say 108. The way that I would go about figuring out a prime factorization on this, because it's even, I already know I can divide by 2. Does that make sense?
Yeah.
Okay, so 108 divided by 2 gives me 54. So 2 times 54 is, well, I don't know if it's a prime factorization because I don't know if this is prime yet. I have to figure that out. I do know that this is prime, so that's good. I can leave the 2 alone because it's prime. I won't be able to divide by anything else. But the 54 is also even, so I know that one can be divided by 2. So what's 54 divided by 2? Divided by 2 is 27. So this 2 is also prime. So, and then I try to divide this stuff. What can I divide for 27? It's not even, so I can't divide it by 2. Usually the next thing to try, I just start by the smallest prime numbers. I start with trying to divide by 2, and then I try to divide by 3, then I try to divide by 5, and I just keep going until I find something. So this one, I'm going to try 3. 27 divided by 3 is 9. So I can stop with the 3 because 3 is also a prime number. But the 9, I can divide by 3 and 3 again. Does that make sense so far?
Yeah.
So I just keep trying to divide until I can't divide anything anymore. And then the prime factorization for 108 is just 2 times 2 times 3 times 3 times 3. Because 2 times 2 times 3 times 3 times 3. They're all prime numbers, and we say it's factored because when the definition of factoring is just writing as things multiplied by other things. And if you checked it, 2 times 2 times 3 times 3 times 3. So 2 times 2 times 3 times 3 times 3 equals 108. Then you can see it right below the 108. 2 times 2 times 3 times 3 times 3.
I see.
So you're just trying to divide it down until you can't divide anymore. That's pretty much prime factorization, and it's a lot of like trial and error basically until you like do it a lot, and then you'll remember stuff. But let's like, do you have time to try?
Yeah, we can do this one. It's only going to be 10 questions. So.
All right, let's see.
We'll just do this one. Got it?
It said Geo has started sharing, but I don't see anything yet. Oh, there we go. Okay, so
this one's different then, right? Or what are they?
Yeah, composite numbers. All that means are numbers that aren't prime. So let me go back.
20.
Like, what is the sum of the first 4 composite numbers? Here, let me share.
Okay.
So I'm not actually sure if 1 is composite or not. I'm going to switch it on my phone real quick. Is 1 a composite number? Is 1 a composite number? So 1 is not a composite number. Okay, so 1 is just the outlier. It's not prime and it's not composite. But all the rest of the ones that I blacked out, these are all composite numbers. And the question was saying, what's the sum of the first 4? So this was composite, this was composite, this was composite, this was composite. 1, 2, 3, 4. So what's the sum of these? So it just means add them together. 4 plus 6 is 10, plus 8 is 18, plus 9 is 27. So I think, is 27 one of the answers?
Yeah.
Okay. So a composite number is just whatever is not prime, and 1 doesn't count. That's all.
Yeah, I don't think I've read it. Would I ever figured that out? I guess if I would have watched videos or something.
Yeah, it's just like definitions at the beginning that you have to get used to, and it's just doing more and more. Which is a true statement about the number 1. This is also just knowing definitions. 1 is a factor of every whole number, since every number is divisible by itself. That might be true. 1 is not a factor of any number because it is neither prime number nor a composite number. So
you, just from what you told me, the last 2 are not right.
1 is a prime. Right, it's not a prime number and it's not a composite number. For something to be a factor, it just means like you can write it times something like 2 and 3 are both factors of 6 because 2 times 3 is 6. But 2 times 3 times 1 is also 6, which means 1 is a factor. And in fact, 1 is a factor of every single number. So it's the first one. The first one is correct. 1 is a factor of all the numbers because you can always write any number as 1 times itself. Yeah. Jamie created a list of the factors of 32. So these are all the things that you can divide 32 by. Which numbers should be removed?
You can divide 1, right? So.
Yeah, 32 divided by 1, that gives you 32. 32 divided by 2, that gives you 16? 16.
Yeah. I would say 6.
Yeah. Yeah, the 6. Because 32 divided by 6 is a decimal.
Yeah, and if you divide it by 5, it'd be...
But all the rest of them, 32 divided by 8, that works out. That's 4. 32 divided by 16 is 2. 32 divided by 2, 32 is 1. So 6 is not a factor because when you do 32 divided by 6, you don't get a whole number. Composite numbers have less than 2 factors. No. More than 2 factors. Okay, can I share on this one real quick?
Yeah, sure.
This will be a quick one.
We're only, 5 minutes in and we're already three questions in.
Okay, so composite numbers 4, 6, 8, 10, 12, 14, let me erase this, 15, 16, 18, and 20. So these are composite numbers, and it's saying like how many factors it has. For any of these composite numbers, I at least have 2 factors because any number, composite or prime, has 2 factors. Because like 4, I can write that as 1 times 4. That's 1, 2 factors.
Okay.
Or I could write 4 as 2 times 2. Actually, this would be 2 times 2, right? 1 times 2. That's 3 factors. I can always do, that's 2 factors. I guess 9 is the same way. All right, what were the options, actually?
Uh, First one, less than 2 factors.
It's definitely not that.
More than 2 factors. Can be that, right? Because you got 3 on that one.
Yeah.
Exactly 2 factors, and then greater than or equal to 2 factors. And the last one?
Greater than or equal to 2 factors. I think it's the last one. Greater than or equal to 2 factors. Well, because 1 is always a factor. What is the question say?
It's composite numbers have.
Okay, composite numbers always have. Composite numbers always have more than 2 factors. It says, is there one that says that?
Yes, that's the second one.
Okay, it's that one. Because more than 2 factors, like you can always do for a composite number, like 9 times 2, that's 2 factors, but then you can always do times 1, so that's always, you can always add in that 1, which means it has either 3 or more, so definitely more than 2. Rathan thinks all factors of even numbers are even, which explains whether Rathan is correct.
I'd say it's a B. I mean C.
Well, he is incorrect. That's true.
Yeah, for sure.
Oh, it's that's also true because like 2 times 3 gives you an even number. Yeah. Manuel created a factor tree and wrote the prime factorization of 60 shown below. Ah, what is Manuel's error?
He's multiplying, right? Or
He's supposed to be multiplying, but
oh, he is. Okay. Even on the after once you got all the numbers, you were like, well, I guess you multiplied them all, huh? Two
yeah.
times 2, or okay.
So to find the prime factorization, to do this little factor tree, you keep dividing until you can't divide anymore. So like the 4, there's something wrong with the 4. Do you know why?
Yeah, because we could have divided the 2 and then by 2, right?
Yeah, the 2 and the 2. So this, like the 3 times 4 times 5, that is a factorization because it's just numbers being multiplied together. But it's not a prime factorization because 4 is not a prime number. You could keep going. And it should be like 3 times 2 times 2 times 5. So which answer
Yeah.
is it?
It's he did not find the prime factors of 4.
Yeah. All right, so try and break this. Oh, actually, since it gives you multiple choice.
I could just do. Well, I mean, I should do it, right? Just to.
Yeah. But let me ask you this: number 2 is wrong immediately. Why?
Yeah, because he didn't. He's not breaking them. He just that's like the first step that he
Yeah, yeah,
used,
yeah.
right?
He didn't break down the 20.
Yeah.
And then the last answer is also wrong because 4, you could still break down a 4, even if that was supposed to be like 2 times 2 is 4 times 4 is 16 times 5. Maybe that's 40. But he still didn't break down the 4. So that's not a prime factorization. So the only ones that could possibly be right are the first one or the third one. And only one of those multiply up to 40.
The third one, right? Because the other one's only going to be 10.
Right, and so that doesn't add up to 40, or multiply up to 40. And 2 times 2 is 4, times 2 is 8. 8 times 5 is 40, yep. Would you know how to do this one?
So for it asking you what number is a prime factor, or what number is a factor, it's not asking you a prime factor, right?
Right. So that just means which number, like when you divide it, 51 divided by whichever one of those numbers, which number gives you a whole number. That's what a factor is.
Okay. That's or 11. So it'd be 17. Well, I'm gonna try the last.
Yeah, I'm gonna try it too.
17. Okay, so the factor just means
it divides evenly.
Divides evenly. Okay.
Yeah. So when you did that, 51 divided by 17, what did you get?
3.
3. So that means 17 is a factor of 51, but it also means 3 is a factor of 51 because you could also you could also do 51 divided by 3 and you get 17. Does that make sense?
Yeah.
Yeah, the 17 and the 3 are both factors of 51.
So what is a factor? So I can write it down. A factor is the, like how you said it.
Yeah, there's 2 different ways that I said it. So one way is a factor is a number that you can multiply to another number to get, I guess, the whole number that you're thinking of.
Yeah.
Actually, so here, this is probably easier to write out. A factor of a number divides it evenly. Like the way you would here. Let me share and I'll write it down.
Yeah.
Because you kind of use notation to make it like understandable, but it uses. Well, you'll see, and then you'll tell me if it makes sense or not. So.
Well, not only that, it'll be on the video, so I can always go back.
Yeah. So a factor of a number x, so any number x is a number, I should say a whole number. Whole number. So no decimals or fractions or anything. Whole number that divides x evenly. So if you start out with a number like 32, then a factor of 32 would be any number that divides 32 evenly. So 32 divided by 2, that gives me a whole number. That means 2 is a factor of 32. Because 2 that divides x evenly. So 2 divides 32 evenly. I can go 32 divided by 2 is 16. So 2 divides 32 evenly. 16 is also a factor of 32 because I can do 32 divided by 16 and I just get the other side, 2. So 16 is also a factor, and then 8 is also a factor of 32. Now the thing that we're doing on this pretest is finding prime factors, which just means like if you get 16 as a factor, you can still break 16 down by keeping on dividing. But that's kind of the basic definition. A factor of a number x is a whole number that divides x evenly. If some number that you pick doesn't divide some other number evenly, then whatever number you picked in the beginning is not a factor of the other one. I think that's probably still confusing, but we'll keep going more. We'll see.
Yeah, I can rewatch it then. Or just divide the number,
Yeah.
I'll find a way.
Yeah, it's I think just with more examples and more problems, it'll click eventually.
So like this one right here.
Ray created a list of factors. Which number should be removed from the list? Okay. Yeah, factors divide. So factors of 48, or factors for 48, should divide 48 evenly. So 48 divided by 1, that's 48, so that works. 48 divided by 2 is 24. You just try them and see which one doesn't divide it evenly.
Yeah, so the 7 is what I got.
Yeah, because that one, when you do 48...
Just from going from the answers.
Yeah. Yeah, you don't have to try all of them because it just gives you options. So, and that's the only one that doesn't divide evenly, right?
Yeah.
Cool.
Gave me like 6.85.
Yep.
This one you can see now.
Each made a factor tree to find the prime factorization of 126. Okay. Which statement explains the accuracy of the student's work? Well, first of all, on the right side, you see how it's 2 times 7
It's too quick, right?
times 9?
Yeah.
Just on that second one, which one can you keep breaking down?
Nine's not a prime number, right?
Correct. So that one would be, it should be 2 times 7 times 3 times 3. So now that brings us to the left side. It's 2 times 3 squared times 7. The tree is correct. And the same with the, like, do you understand the notation? Just squaring it just means 3 times 3?
Just because it has to, yeah, because it's times 2, I guess, 2 times 3.
So
I mean, I've seen it before. I just don't.
Right. So let me share real quick, and then this one will be pretty quick or pretty easy.
I've seen some. They have different numbers though, not just 2.
Yeah.
Right? 3.
So the common thing. So like, if you have 3 squared, so 3 squared. That means 3 times 3, not 3 times 2. So it doesn't mean this one times this one. It means this one
Oh, it means 3 times 3.
times itself this many times. So if you did, if you had like 3 to the 5, that means 1,
3 times
3.
Five times.
Yeah. 5
Okay.
times. So that's what they. That's just the notation.
What do you mean?
That means that. So
Okay.
on that left side, when he writes 3 to the 2, you could replace it with 3 times 3. So it would be, for the problem, 2 times 3 times 3 times 7. And all of these are prime numbers. So that is a prime factorization.
Correct.
He just wrote this part with the exponent notation.
Nice.
So that is correct. So what do the answers say? That's all right. So we already know that Josh's solution is not correct. So that second one is wrong.
So the answer would be A because both solutions are correct, which that's wrong. Neither solution is correct, which we just figured out that she did.
Yeah. So yeah, Lena's solution is correct because it expresses 126 as a product of prime factors. Yep. All right, let's see that. Oh, cool.
100%. No, I'll just see the next one.
Yeah,
I just watch
title.
Videos. Whatever.
Title of that.
Factors and so.
So
if not, we can do it. I don't know if we want to tomorrow or whenever after Saturday, whatever.
Yeah, let's do tomorrow.
Okay.
But multiple, so like factors are what divides a number evenly. Multiples are just like when you multiply a number. So, that's a weird one.
Okay, so instead of, I see what you're saying, right? So instead of them having it'll be, what can I multiply to get that number?
Yeah, to build it up instead of breaking it down. It's like, if you start out with 2 and you multiply it by a whole number, that number that you get is a multiple of 2 because you multiplied by a whole number. That's the idea.
Oh, okay.
So like 2 times 3 would be 6. So then 6 is a multiple of 2 because there's a whole number that you can times by 2 and then get 6.
Okay.
It's still with factoring. I wonder how that one's gonna be, but I know. Well, you could try it and then we'll talk.
I mean, I'll watch the videos and then I'll just wait for tomorrow.
All right, sounds good, man.
All right, brother. Have a good night.
You too. Bye.